In this video, we're going to talk about three-dimensional figures. We've been talking about areas of various shapes, and now we're going to shift gears and kind of start talking about three-dimensional figures. And the first thing we need to know about three-dimensional figures is something called a plane. And a plane is a two-dimensional flat surface that extends in all directions. So these kind of exist in space. So if you can imagine a giant sheet of paper or a giant sheet of wood that extends in all directions and it's flat and it goes on forever, that is a plane. Now that's a basic geometric shape in three-dimensional geometry. And then so from that we can create things called solids, and solids are something we refer to as three-dimensional figures. And we can create things called polyhedrons, and those are three-dimensional figures that have polygons as faces. So in this picture here we can see that all these objects here are solids, but not all of these objects are polyhedrons. So we have the green block here is a polyhedron, the red cube is a polyhedron, this purple pyramid is a polyhedron, but then we have these three other objects, the sphere, the cone, and the cylinder, which are not considered polyhedrons because not every face or every side is a polygon. Parts of polyhedrons. So we're talking about these figures that are made up of polygons, and they have specific parts that have specific names, and one of those is an edge. And an edge is a line segment where two faces of the polygon intersect. Basically, it's one of these line segments right here or here. These are all edges of a polyhedron. We also have a vertex, or plural vertices. These are the corners. So whenever you have a corner on a polyhedron, that's called a vertex. And then the flat parts, or the flat sides of a polyhedron, are called faces. And then we have diagonals, which are lines that pass through the interior of a polyhedron that connect two vertices. So if you connect two vertices and kind of pass through the polyhedron instead of along the face or along an edge, that's a diagonal. And then skew lines are lines that do not intersect and are not in the same plane. So if you can think of parallel lines, those are lines that don't intersect, but they're in the same plane. They're on the same flat surface. So if you draw two lines that don't intersect on your paper, those are parallel. Those are not skew. Now, if you could imagine just taking one of those lines and tilting it up into space, then they would still not intersect, but they would not be in the same plane anymore, and they would be called skew lines. So if you're imagining this cube here, imagine the line that goes through D and C. You kind of put on your three-dimensional thinking hat, and then imagine a line that goes through E and A. Those two lines would be skew. They would never intersect, and they're not in the same plane. We couldn't lay them on a flat piece of paper because they go in different directions in space. So that is what we're talking about when we talk about skew lines. And those are all the parts of a polyhedron. We're going to be using that vocabulary. So then we have types of polyhedrons. There are basically two types of polyhedron. There's the prism and the pyramid. These are the two basic families of polyhedrons, and both of these polyhedrons are defined by their bases. And a base is the shape or the polygon that defines the polyhedron. It tells us what kind of polyhedron we're dealing with. And a prism is a polyhedron that has two identical parallel bases, and all the other faces are rectangles. So if you can see this prism, it has a pentagon at its base, and there's another identical one at the top. So the pentagon is what defines this prism, and all the other sides are rectangles. The two pentagons are connected by 5 rectangles. Then we have a pyramid, and a pyramid is a polyhedron that only has one base, and all the other faces are triangles. So again, looking at this pyramid, there's a hexagon at its base, so that's the shape that defines this pyramid. It's what makes it what it is, and all the other faces are triangles. So that's the main difference between a prism and a pyramid: the number of bases that it has and what shape all the other faces are. So again, in a prism, you have two identical bases, all the other faces are rectangles, and in a pyramid, you have one base and all the other faces are triangles. So here is a few of the types of prisms and pyramids we're going to be talking about. And again, the shape of the base is what defines how we name and classify a polyhedron. So looking at this first one, we have a triangular prism because it has two identical triangle bases. If you could imagine that triangle off in the background there has two identical triangles, and all the other sides are rectangles. So we would call that a triangular prism. We also have a square prism. We have a rectangular prism. We have a pentagonal prism, or pentagonal prism, I guess, depends on how you want to pronounce that, because it has two parallel identical pentagons, the hexagonal or hexagonal prism. And then we have an octagonal or octagonal prism. And then below we have the types of pyramids. And again, these are named by their bases. Here we have a base that's a triangle. And again, all the other sides are triangles. This is a triangular pyramid. Here we have a square pyramid because the base is a square and all the other sides would be triangles. A rectangular pyramid, pentagonal pyramid, hexagonal pyramid, or an octagonal pyramid. So you can see that the name of the polyhedron depends on what kind of base it has. The base determines what kind of solid you have. And then, of course, we have these two other types of solids. We have the cylinder, which is a solid with two parallel identical circle bases. It's kind of like a prism with circle bases. And then we have the cone, which is a solid with one circle base. So it's kind of like a circular pyramid. So identifying all the parts of our polyhedrons. Here we were asked to identify what the figure is, name it, and then name the bases, faces, edges, and vertices, then identify a pair of skew lines. Well, what kind of shape is this? Well, it only has one base, and that base is down here, and it has 5 sides. So this is a pyramid, and since the base is a pentagon, it is a pentagonal pyramid or pentagonal pyramid. That's what type of solid this would be. And then we have the base, which was B, C, D, E, F. And then the other faces we have A, B, F. I'll try to keep track of these here. A, B, F is this triangle here. We have A, F, E, which is the triangle in the back. We have A, E, D, which is the triangle on the back right. We have ADC, the triangle in the front right. And we have ACB, which is the triangle directly in front. And then, of course, that base again, BCDEF, the bottom one there, are all the faces. The edges are all line segments, so we write those as line segments, and we have all the line segments coming down from the vertex A. So we have AB, AC, AD, AE, and AF. And then we have all the line segments that make up the base. We have BC, CD, DE, and EF and FB. So those are all the edges on our pyramid. And then the vertices, those are just all the corners. So that's A, B, C, D, E, and F. And then there are several skew lines in this diagram. So just one pair of them they have listed here as AB. So if you can imagine a line going through AB, and CD, these two lines in space would not intersect. So let's try it with this figure right here. Here is a solid. What is it? And let's name the bases, faces, edges, vertices, and name a pair of skew lines. Well, this has, again, one base, and all the other sides are triangles. So this is a pyramid of sorts. And since the base is a triangle, this is a triangular pyramid. And if we want to name the base is B, C, D. The other faces would be here, and that would be A, B, C. We have A, C, D. And the one in the back, A, B, D. The edges would be AB, line segment AB, line segment AC, line segment AD, and then all of the line segments that make up the base. We have BC, BD, and finally CD. The vertices are just all the corners, so those would be A, B, C, and D. And then naming a pair of skew lines, we could think of in space AD and BC would be skew lines. So if you kind of visualize that pyramid in three-dimensional space, those two, if you extend them, would never meet. So AD and BC would be a pair of skew lines on that segment. Let's take a look at the next figure here. This is a circle base, and only one circle base, so we call this a cone, and the base is a circle, and specifically it is circle C. We name a circle by its center. Faces, well, since none of the other sides are polygons, it has none. It has no other edges. It has one vertex, and that would be B. And there are no line segments that make up the sides, so this has no skew lines. That was easy. So that is the parts of our polyhedrons. And then finally, we want to talk about this concept of a cross section. And a cross section is when we take a solid and we slice it, and then the resulting two-dimensional shape is called a cross section. Now I'm going to attach another video to this lesson that explains cross sections a little bit better than I can visualize them, so we'll go into more of that in the video that I'll attach. But real quick here, if you imagine these kind of orange cuts that we're cutting these objects in, so we cut this pyramid here, and it's going to create a shape when it slices it right here. And if we describe that shape, if you look down on that from the top, that's going to be a square. So we would say that this cross section results in a square. The same thing here with this prism. If we kind of cut that blue shape right there is going to be another square. If we cut this prism, it's going to look a lot like its base, and this is going to be a pentagon. So the cross section here would be described as a pentagon or a pentagonal shape. And if we cut this pyramid vertically, oops, hello, lost my screen. If we cut this pyramid vertically, we're going to get a cross section that's a triangle. If we cut this prism vertically, we would get a rectangle. And if we cut this cylinder horizontally, we would get a circle. So when we're talking about cross sections, we're talking about the shapes that result from a slicing of a three-dimensional object.